Assalamu alaikum, Mr. Zring and my fellow students. My name is Ibrahim Al-Mutawa and my partner Ibrahim Lees. Today we'll be talking about naming molecular shapes. First off, a molecule consists of at least two or more atoms. Usually, a molecule consists of two or more atoms combined in a definite ratio. The atoms, however, can be from one element, like oxygen, O2, or from multiple elements, like water, H2O. Molecules occupy a variety of shapes. These shapes are usually presented in the three-dimensional shape, which is important in determining the molecule's physical and chemical properties. However, two-dimensional shapes are often popular in hand-drawing presentations. For example, CO2. Although this is a flat molecular shape, we'll be talking about more complex molecular shapes later. Anyways, to predict the shape of a molecule, you must examine the Lewis structure of the molecule. You must also take into account the valence shell electron pair repulsion theory, which can be abbreviated and referred to as the Vesper theory. According to this theory, the shape of a molecule is determined by the valence shell electron surrounding the central atom. For example, N2O. As you can see, there are 8 valence electrons surrounding the central atom. These two pairs of electrons can be represented each by a single bond. These two bonds are negatively charged. Therefore, they will try to maximize the repulsion between each other, which is 180 degrees. The lone pair of electrons will occupy space in the molecular shape because it is composed of electrons, which means it affects the repulsion distance. However, it is not really visible, especially in the three-dimensional shape. A bubble will be representing the lone pairs. The surrounding atoms, on the other hand, will be represented either by their symbol or by their circular shape, based on whether the molecular shape is two- or three-dimensional.
Now it's time to draw the molecular shapes. As my partner mentioned before, there are a huge variety of shapes. These shapes are based on the steric number that we were able to extract from the Lewis structure. This symbol means that the atom is projected outwards, while this symbol means that this atom is projected inwards. An example for steric number 2 is carbon dioxide. This is the Lewis structure of carbon dioxide. There are two multiple bonds here, as you can see. Each one counts as 1. So if you add them together, you will get the steric number 2. Okay. Also, because there are only 3 atoms here, they will tend to force maximum distance, which is 180 degrees apart. Steric number 3 is called trigonal planar. First off, the original, AX3. A represents the central atom and X represents the surrounding atoms, and the subscript 3 represents how many surrounding atoms there are. An example would be BH3, where B is the central and the H are the surrounding. This is the shape of this molecule. The second part of this family is called bent, AX2E. The same thing applies here, except that the E is the electron pair. However, the actual pair doesn't really show in the molecule, so it appears to have a bent shape, which is the name of the molecule. When I say original here, it just takes the name of the family. So this would be called trigonal planar. You should also know that the degrees of this family would be 120 degrees apart. All of them would be the same. Steric number 4 is the tetrahedral. There are 3 parts to the tetrahedral family. First off, being the original, the example would be CH4. This is straightforward. I've already explained what these two symbols mean. The second part of the tetrahedral family, called trigonal pyramidal. An example would be NH3. And these are the electron pairs, and these are surrounding atoms and the central atom. It is called the trigonal pyramidal because it takes the shape of the pyramid. This is actually empty, doesn't show, so it would be like a pyramid. Third part of the tetrahedral, bent. It's called bent. An example would be water, H2O. It takes the shape, why it's called bent, because it takes the bent shape of H. These two would not show, so it will be taken. You should also know that the degrees between each of these atoms, surrounding atoms, is 109.5 degrees apart. Theorem number 5 is the trigonal bipyramidal. First off, the original, AX5. An example would be PCl5. The same thing applies here, the X and the A and the subscript. It is called trigonal bipyramidal because there's the triangle in the center, and then there's two pyramids at the top and the bottom. Bi meaning two. Second part of the trigonal bipyramidal, the seesaw, AX4E. An example would be the SF4. This is the shape of the molecule, the electron pair, the central, and the surrounding. It's called seesaw because it is like the game the children play, the seesaw. When the one sits down, the other goes up, and same thing. Where these two are the base, and these are the seats for the children. The third part of the trigonal bipyramidal is called the T-shaped, AX3E2. An example would be BRF3. Same thing applies here, but it's called the T-shape because it has the T-shape. That's straightforward. The fourth part of the trigonal bipyramidal, it's called linear, AX2E3. You are familiar with the linear from the sterics from previously. It is straight. You should also know that the degrees between these atoms are 90 degrees. So meaning the top with the sides are 90 degrees, and the sides, these are the sides. So each of these would have 120 degrees apart. For steric number 6 is the octahedral. This is the basic structure of the octahedral, and this is an example, SF6. The same thing applies here, the central, the surrounding, and the angles here are all 90 degrees. So all of them here will be 90 degrees for all of them. Molecules have numerous shapes composed of two or more atoms. These shapes are very important in determining the chemical and physical properties of a molecule. Also, those structures play a very important role in determining the shape of a specific molecular formula, in which the steric number plays an essential role as well. Thank you and goodbye.
The valence electron shell pair repulsion theory, which can be abbreviated and reverted to predict the shape of a molecule. Remember, all steric number 2 are called linear.